Okay, at this point we just need to evaluate this expression for k using these values with their uncertainties in order to get a value and an uncertainty for k using the program galcp. So let's open up a browser. We'll search on CB Physics. I'll just type that in there. It's the first item. We're looking for first semester downloads, math resources. I'll scroll down a little bit. There's galcp. Open it up. Double click. Open. And let's take a look at this. We've got 1, 2, 3, 4, 5 variables. So we'll go ahead and use 5 variables there for galcp. Type in a 5 right here, and then gonna switch back. We're evaluating k, and we got M, D, and L coming up. I'll go K and M. That's what I need to remember. So I'll double click down here. Evaluating k, hit return, hit k there, hit return, and then the next one I think is D, no M, and 0.118. So I'll type in M, return, hit return both times, and then 0.118, return. And the error in M is 0.2. 0.002, this thing knows nothing about units. So I'm going to hit return there. The return, I call the enter key the return key. So same difference, hit enter or hit return, whatever you prefer to call it. So this one becomes a D, return, D, return, or enter. And the values for D were 0.134 plus or minus 0.2. 0.134 plus or minus 0.002. Seems like a coincidence that it's the same as the previous one, so let's make sure. Okay, the mass was plus or minus 0.2 grams, and this plus or minus 0.002 in both cases for the lengths. So probably okay there. Get back down to our expression for K. I'm up to L, 0.025 plus or minus 0.001. Double click, lowercase l, return, L, return. I forgot those values. 0.025 plus minus 0.001. 0.025, return, 0.001, return. Okay, gotta double click down here. What am I changing that to? We're up to omega sub RPM. I think I'll just call that RPM rather than write out the whole word omega. So I'll call it RPM 96018. So RPM return, RPM return 960 return 18 return. Okay, that looks pretty good. Then the next one, X 0.06 plus minus 0.002. So X return, X return, and I forget that one, but this was 0.002, and I think this was 0.06. Checking 0.06 plus minus 0.2. And then we get these two constants which have no error associated with them, 2 pi and C2. So now I want to type in this expression for K over right here. So it's equal to, I only had 3 values there. Let's look at the expression for K. I wonder if I can make it so that I can see them both at the same time, so I don't have to keep going back and forth. Here's my expression for K, and then over here, if I make this a little bit smaller, I can type it in there. So I think I'm going to go with, I'll hit the equal sign, and then I want the M, so I'll go to the corresponding value for M, click on it, and hit return. That was not the way to go, but I've got the M in there, so I click back on here, click that, and I want times, open parentheses, the D, so I just click on it, I don't hit return, and then minus, I want the L, which would be this one, /2, close parentheses, and then times, and this is a product of 3 variables, so I don't really need the parentheses there. I choose to leave them out. I want the RPM variable in there, the 960, and then times. C2 was pi. I actually gotta look at that. What was the definition of C2? So it's the product of C1 and C2. So it's 2 pi. So I'll go times 2 times pi. The way you type that in there is the word pi with open and close parentheses right after it, and then times 1/60, or I'll just go /60. Okay, and then all of that needs to be divided by x. So I can actually hit just a /x in that things do, the algebra is done left to right. If you prefer, you can put parentheses there and there, but I'm just going to go /, and then here's my x variable right there, and type that in, and I've got an expression for K, which unfortunately does not match what I calculated for K at the means. So I better do a little bit of checking. You might remember with a calculator, I got 2413, and here I'm getting 24 point something, off by a factor of 100. So let's. I'm gonna pause this and check for my mistakes. Okay, I got it. And the expression for K. I'm pretty sure I forgot to square this. Let's take a look down here. So let's fix that up. I got to square this. So I'll fix that up in my expression for K. And over here, I've got to square the whole thing, my expression for omega, including the conversion factors. So I'll put parentheses around that entire expression, and then I'm going to hit Shift-6 or caret and then 2. So raising that to the 2 power, hit return, and that comes out to agree more closely with the value that I had over here. I'd say any difference there is just round off error. So 2413 here, 2413, and in here I got 2415. It rounds to, I'd say it's just round off error in that 4th place. Okay, so now I got to copy this thing. I'll do a Control-C. Copy it all the way down. So I've selected all of these by clicking on the first one and then sliding all the way down to the last one. I do want to keep this in the screen so you can see it though. Okay, so I've selected all these. I've already done a Control-C. I'm just going to hit Control-V. Obviously you could use the copy and the paste instead of Control-C and Control-V. They're the same thing. And I think I'm there. Let's hit F9 to do a recalc. Let's take a look at our result. Does look fairly Gaussian. Check, make sure we got all the variables in there. We got 5 variables: M, D, L, and what I call it omega RPM. I just called it RPM, and X. They all look, they closely conform to the Gaussian. These values actually chosen randomly with Gaussian distribution. So I'd say we've got our answer. Let's take a look at the mean, 2424. I'm going to actually go with our calculated value up here, 2115. It is saying there's quite a bit of error or uncertainty in that digit. The second digit after the 2, we've already got some uncertainty of in the ballpark of 143. I want to see, I'm going to hit F9 a couple of times. F9 and keep looking at this value, see how it changes. So 142 to 138, it's in the ballpark of 140. F9 again, let's calculate, and 134, so that would drop it down to 130 to 2 sig figs. 130 or 140, I'm only going to quote 2 sig figs. 140 again, it rounds to 130. 140 again. One last time. Yeah, 140 again. I'm going to quote it as 140, so call it, the error is occurring in this digit already, so I'll just write 3 sig figs in the answer, and 2 sig figs in the error is more than enough. I think it's appropriate. So I'll say K is equal to, we got 2414. So I don't want to indicate, this is actually, these are guard digits out here. I think it was 15, right? I want to look at the value up here, 2415. So I'll write it down as 2415. It's more digits than I need. 2415 plus or minus 140. You could call it 135. That's a judgment call, but again, we don't even know what this digit is, and this is certainly an estimate. Plus or minus 140, and our units were newtons per meter. So that does it for SAC 116, problem number 6. Oh, wait a second. We've got to print this out. Let's see what all we want to print. I'll go from here. I'd like to get all of these graphs in, and I want to see some of the values over here. So I'm going to select this region and then see if that's enough. Actually, I think I'll go one more over. Okay. Yeah, it tells people how many values are outside the range. And then, okay, let's try, I'm going to go with File, Print ... See what we got. I want to print the selection, and I want to preview it, see how that comes out. I'm missing all those other graphs, so I'll do Setup. I'm going to select Landscape. That looks a little bit better, but I'm still missing some. I gotta find the menu where it says Fit to One Page. There we go. Under Setup with Print Preview, we're okay. Now that's what I want, so I'll go ahead and hit Print. and it's doing it. It's printing for me. Okay, now I'm all done with SAC 116, problem number 6.